All right, so ready to dive into the world of algorithms.
Always ready.
I think a lot of people hear that word and their eyes kind of glaze over, but
Yeah,
algorithms are running the show behind pretty much everything we do online these days,
it's true.
and even a lot of things offline too.
Uh-huh.
So we're going to take this article, The Science Behind Efficient Algorithms,
Okay.
and really try to break down not the nitty-gritty coding stuff, but like what
Yeah.
makes a good algorithm,
Mm-hmm.
why should we care, even if we're not programmers,
Right.
and kind of like what's on the horizon.
Yeah, it's a pretty exciting time for this stuff.
It is. It's easy to just think of it as like, oh, that's techie stuff.
Mm.
But, okay, simple way to think about it. Algorithms, kind of like
Oh.
recipes for computers.
Yeah, I like that analogy.
And you follow the steps, you get the outcome.
Exactly. And just like with a recipe,
Hmm.
you can have, a recipe that's really complicated, takes forever, makes a huge mess.
Right.
Or you can have one that's elegant, efficient, gets you to the same tasty result, but way better.
Exactly. So it's not just about, like, does the computer do the thing?
Yeah.
It's about how well does it do the thing?
Yeah, and especially now,
Yeah.
we're dealing with so much data
Oh, yeah.
that if your algorithms aren't efficient,
Right.
things just grind to a halt.
So where do these things actually show up? I mean, the article mentions it's not just, like, hardcore software stuff.
Right, yeah. So think about something like just doing a Google search.
Okay. Yeah. I use that every day.
Right. You type in a question, boom, you get millions of results.
Mm-hmm.
But they're organized. Hopefully the most relevant ones are at the top. That's algorithms at work,
Wow.
sifting through billions of web pages,
Okay.
or using GPS, right, to get somewhere.
Yeah. Can't live without that.
Right. An algorithm is figuring out in real time what's the fastest route, taking
Mhm.
into account traffic, accidents, all that stuff.
Okay. So it's
And even something like, Netflix recommendations, that's algorithms too, looking at what you watch, what other people like you watched.
so it's all about making those suggestions that keep you hooked.
Exactly. It's everywhere.
Okay. So this efficiency thing, the article keeps coming back to that.
Yeah.
And they use this term big O notation. Which,
Oh, yeah, that can sound scary.
yeah, like this could be a math lesson. I'm not sure I signed up for
Oh,
that.
no. Think of it like this. Imagine you're trying to find a book in a library.
Okay.
You could just wander around randomly.
Right. That'd take forever.
Right. But if the library is well organized, things are categorized, you find it way faster.
So like a well-organized library has good big O.
Exactly.
Okay. I kind of get it.
Yeah.
So are there like different levels of big O? The article mentions like ON squared.
Yeah, those are just ways of kind of describing how much slower things get as the problem gets bigger.
Okay. So without getting into like the math formulas and stuff, what's the key takeaway there?
The takeaway is there's no one best algorithm. It's about choosing the right one for the job. Like sometimes speed is everything, sometimes you need accuracy, even if it takes longer.
So it depends on what you're trying to do.
Exactly.
Okay, that makes sense. Now, the article goes on to talk about like techniques for making these algorithms smarter, and they use some fancy names. Divide and conquer, dynamic programming.
They do like their jargon, don't they?
Yeah, a little bit. Can we demystify that a bit?
Of course. So divide and conquer, it's literally what it sounds like.
Okay.
You got a huge problem, you break it down into smaller chunks, solve those, then put the pieces back together.
So like if I have a giant to-do list,
Yes.
I don't freak out at the whole thing. I break it down into manageable tasks.
You divide and conquer. And what's cool is that this isn't just a computer thing, it's how we solve problems in real life too.
That's a good point.
Yeah.
What about dynamic programming? That one sounds a bit more mysterious.
It's a bit more technical, but basically it's about being clever and not repeating work. Imagine like climbing a staircase. Instead of starting from scratch each step, you could somehow store the effort from the previous steps and reuse it.
So it's like having a cheat sheet for problem solving.
Yeah, kind of. You store solutions to smaller parts of the problem so you don't have to recalculate them over and over. Saves a ton of time.
I can see how that'd be powerful, especially if you're dealing with like massive amounts of data.
Absolutely.
And the article even gives some like Python code examples for these techniques. We won't get into the code itself, but it's good to know these aren't just like theoretical ideas. There's actual code that does this stuff.
Yeah, it's all very real world applicable.
So what other tricks of the trade are there?
Well, one that's kind of interesting is called greedy algorithms. These are all about making the best choice right now, even if it might not lead to the absolute best solution overall.
So it's a bit like following your gut. Sometimes it works out great. Sometimes you're like, oops, should have thought that through more.
Exactly. But sometimes speed is more important than perfect accuracy. Think about like finding the fastest route in rush hour. You don't have time to analyze every single possibility. You got to make a decision and go.
Yeah. In those cases, good enough is better than perfect, but late.
Right. And then there's hashing. This one's all about speed, like super fast information retrieval.
So if I need to find something instantly,
Yeah, think of it like having a perfectly organized filing system. You know exactly where everything is, no need to search.
okay, that makes sense. I'm starting to see how all these different approaches, like each one has its strengths and weaknesses.
Yeah, that's the key.
So you got to know which tool to use for which situation.
Right, just like a toolbox.
Okay, this is giving me a whole new appreciation for what's happening behind the scenes of like all the apps and websites I use. But we've been kind of theoretical so far.
Hmm.
I'm ready to see how these algorithms actually play out in the real world.
Well, hold on tight, because that's where things get really exciting.
All right, bring on the real world examples.
Let's do it. Okay, so real-world algorithms.
Yeah, let's get concrete.
Let's start with something, everyone uses search engines.
Oh yeah, Google, Bing, all that.
Exactly. You type in a question, you get like a zillion results back.
Right, but somehow they're usually like pretty good. The top ones are what I'm looking for.
That's because there are really sophisticated algorithms at work there. One of the most famous is called PageRank.
PageRank, okay.
It's how Google figures out which web pages are the most important, the most authoritative, and then it uses that to rank the results.
So it's not just looking for like, does this page have the words I typed?
No, it's much deeper than that. It's looking at how many other websites link to that page, kind of like a vote of confidence.
Oh, that's interesting. So a page with lots of links is probably more trustworthy, more relevant.
Exactly. And PageRank is constantly evolving. Google's always tweaking it.
Right.
But that basic idea of like analyzing the web as a whole to figure out importance.
That's how they sort through billions of pages?
Exactly.
Yeah.
Pretty amazing, right?
It is. Okay, so search engines, that's one big one. The article also talks about how algorithms are like revolutionizing finance.
Oh, yeah. That's a whole other level.
I've heard about like high frequency trading where computers are making trades in like milliseconds.
Yeah. And that's all driven by algorithms.
So it's not human traders anymore.
Well, there are still humans involved, but they're basically designing the algorithms
Right.
that then do the actual buying and selling super fast based on like market data, trends, all sorts of complex stuff.
It's almost like they can predict the future.
Well, not quite, but they're really good at analyzing vast amounts of information
Right.
and making decisions much, much faster than any human could.
So in that world, like every millisecond counts.
Yeah, it's about speed and efficiency.
Yeah.
And these algorithms, they're constantly learning too. They're being refined and updated all the time.
It's kind of scary, but also kind of cool. Speaking of things that are both scary and cool, GPS.
Mm-hmm.
I rely on that all the time.
Oh, yeah. GPS is another amazing example of algorithms in action. Think about it. You put in an address, and your phone or your car figures out how to get you there, even if you've never been there before.
And it usually does a pretty good job, even with traffic and stuff.
Right. And that's because there are these really clever algorithms. Like you may have heard of Dijkstra's algorithm or a search.
Okay, those names I have not heard of.
They sound complicated, but what they do is basically calculate the shortest or fastest path between 2 points.
So they're like constantly analyzing maps and traffic data and everything.
Yeah, and what's really impressive is they do it in real time.
So if there's an accident or something, it can reroute you.
Exactly. These algorithms have to be super adaptable.
Right.
Because the real world is always changing.
It's like having a personal navigator in your pocket, but way smarter than any human could be.
Exactly. And this idea of real-time decision-making, that's becoming even more important as we move towards things like, self-driving cars.
Oh, yeah, that's got to be a whole other level of algorithms.
It is. I
Yeah.
mean, for a car to drive itself, it needs to constantly be analyzing its surroundings, making decisions about like speed, steering, braking.
It has to be right all the time.
Right. There's no room for error. So the algorithms behind self-driving, they're incredibly complex.
It's mind-boggling to think about. Okay, we got to talk about AI and machine learning too, because those seem to be all about algorithms.
They absolutely are. At their core, machine learning and AI, it's about teaching computers to learn from data.
Right.
And how do we do that? Algorithms.
Mhm.
Whether it's like a Netflix recommendation system figuring out your taste in movies,
Right.
or a medical AI that can help diagnose diseases,
Yeah.
it's all about algorithms analyzing patterns, finding connections that humans might miss.
So the more data they have, the smarter they get.
Exactly. That's why these huge data sets are so valuable in AI research.
It's like they're learning to think in
Yeah.
a way.
Well, in a way, yeah, they're not thinking like humans, but they're becoming incredibly good at certain tasks.
This is blowing my mind a little bit. It's like algorithms are everywhere. We just don't always see them.
They're the invisible force behind so much of our world.
And not just in like tech stuff, but also in things like healthcare, like you mentioned.
Oh, yeah, there are algorithms helping doctors diagnose diseases earlier,
Wow.
helping to personalize treatment plans. It's having a huge impact.
It's incredible to think about. So we've got all these amazing applications,
Mm-hmm.
but I also can't help but think about, like, are there downsides? Are there risks with all this reliance on algorithms?
Yeah, that's a really important question.
Because they're making more and more decisions for us, it seems like.
Right. And we have to be very careful about how we design them, how we use them. We don't want algorithms to perpetuate biases or make unfair decisions.
So it's not just about the tech itself, it's about the ethics of it all.
Exactly.
Yeah.
We need to make sure these powerful tools are used for good.
It's like we're entering this whole new era
Hmm.
where algorithms are shaping society, and we need to be really thoughtful about it.
I completely agree. It's a huge responsibility.
This is definitely making me think, okay, so we've seen the real world impact.
Yeah.
What's next? What does the future hold for this world of algorithms?
Well, the future is, in a word, exciting, but also maybe a little unpredictable.
Okay, I like a little bit of mystery. What does the article say?
So the future of algorithms, it's like we've gotten a glimpse behind the curtain, right?
Yeah, we see the gears turning now, but where's it all heading? The article talks about some pretty wild stuff, like quantum computing.
Yeah, that's one of the big ones. It's still early days.
Right.
But quantum computers, they have the potential to completely change how we think about algorithms.
I gotta be honest, that whole quantum thing, it's a bit over my head.
It's definitely mind-bending. But basically, quantum computers, they use the laws of physics at a tiny scale, like subatomic particles, to do computations in a way that's totally different from our regular computers.
So it's not just about making computers faster, it's a whole different kind of computing.
Exactly. And for certain types of problems, especially really complex ones, quantum algorithms could be like exponentially faster.
Okay, so what kind of problems are we talking about? The article mentions cryptography, like code breaking.
Yeah, that's one area where quantum computing could be a game changer. A lot of our online security, like banking, e-commerce, it relies on encryption that's hard for current computers to crack.
Right.
But quantum computers might be able to break those codes much faster, which, that has big implications.
That's a bit scary. So it's like a double-edged sword, this quantum stuff.
Definitely. Huge potential benefits, but also potential risks we need to be thinking about now.
Okay, what else is on the horizon? The article also talks about big data being a challenge for algorithms.
Oh yeah, that's a big one. We're creating data faster than ever before, like from sensors, social media, everything.
Right, it's an explosion of information.
And our algorithms have to keep up. So there's a lot of work being done on like distributed computing, where you use lots of computers working together.
Like a team of computers.
Exactly, to process these massive data sets.
But even with that, it seems like it'd be tough to stay ahead of the curve.
It is a constant challenge. And it's not just about volume, it's also about the variety of data and how fast it's coming in.
So algorithms not only have to be powerful, they got to be flexible too.
Exactly. They need to be able to adapt to new types of data, new sources, and make decisions quickly.
Wow. So we've covered a lot of ground here.
We have, from the basics of what an algorithm is to all these mind-blowing applications and future challenges.
I'm honestly kind of amazed by how much these algorithms are shaping the world, often in ways we don't even realize.
They really are, and it's only going to become more so in the years to come.
I feel like this deep dive has given me a whole new perspective. I'm definitely going to be paying more attention to the role of algorithms in my life now.
That's great to hear. I think the more we understand about this stuff, the better.
It's both exciting and a little bit daunting, to be honest.
I agree. But like with any powerful tool, the key is understanding how to use it responsibly, how to shape it for good.
Well said. Well, I think that about wraps up our deep dive into the world of algorithms.
It's been a pleasure exploring with you.
The pleasure was all mine. And to everyone listening, we hope this has sparked your curiosity about the amazing world of algorithms. Keep learning, keep exploring, and until next time, happy computing.